Right, it's recording now.
Okay, so as Paul said, we've got the lysimeters here, and then the ensembles over there. They're basically like ground level rain gardens, and then the swale up there, which Eleanor will talk about. And really the difference between the lysimeters here and the ensembles is these are raised up above ground, and these are ground level, so they're going to be receiving runoff and surface water, overland flow from the surrounding areas. And these are all kind of like part of our living laboratory, so they contribute towards the NGIF data, and we've got like some obvious sensors here. So do you know what that's looking at? Oh, so we were talking about this earlier. So net radiometer, measuring kind of measuring the sunlight that the plot receives, and then we've got wind speed, relative humidity, and there's a whole host of other variables here. And then also within the plots, and this isn't the nicest because it needs weeding, but we do have loads of hidden sensors within there. So
Just getting you an example, probably. So basically, you're measuring what's coming in, what's happening within it, and then what's coming out of the plot.
So it's like a mass balance. We've got the rainfall coming in, so we've got a rain gauge here, and then within the cabinets, which I'll open up, we have two tipping bucket flow gauges, so they measure like the outflow, so we can kind of work out like inputs, outflows, and any storages within there as well. So if I open this one up.
I'll let you go on.
Picked a messy one. But I don't know whether you can see down.
Daniel, let them have one turn each afterwards to look, and then let them have a go looking, one by one.
Yeah, sure. So under here we have like tipping bucket rain gauge flow gauges, so they'll measure the outflow. They're connected at the bottom, and then in here these are all the sensors wired up to a data logger. So if I move out the way and you want to take a closer look. And within the plot surface here we have, I think in this one we have 50 sensors all embedded within here, so measuring things like volumetric water content, soil temperature, there's, what else is there? Permittivity as well, so we can kind of like understand water movement through the soil. And on top of there I've just put some of the sensors which are in the soil as well. So that weird kind of screw one is like a soil moisture probe. So in here we have depths every 10 centimetres down to the bottom, measuring these variables. There we've got the top of the sensors. We also have some cold sensors in there. It's got like so we've kind of graded the soil, so we've got here this kind of weird growing media here, which is a recycled aggregate. So you have like the large quarry waste there, and then there's some organic matter, and then some grass as well. So the idea behind this was to try and recycle some material that we couldn't use elsewhere. And then we have a 2 to 6 millimeter kind of limestone. It almost looks like cat litter, and that's basically like a transition layer to stop the fibres going through. And then right at the bottom we have a thicker layer of like drainage gravel, which is like some larger rocks and stuff, and so that has like quite large pore spaces, and that allows the water to kind of go through. And then right at the bottom we have it's like so yeah, we get a bit of like kind of mud coming through, in the sump under there, but it does get filtered out quite nicely because we've got that graded soil profile going through. Any other questions? So again, over here we've got the actually I'll go and grab sorry.
I should grab that. So each lysimeter is doing different experiments. So the one at the top's looking more at the heat transfer and what it can capture within it, and whether you can use that as a resource in itself to heat pipes. We've got carbon capture further down and just different vegetation structures. Some have got just bare grass, which is almost like control ones, and then the others are, as you can see, the one at the bottom's got an awful lot of vegetation growing, and the rain gauge underneath that, I downloaded the data not long ago, and there was no rainfall in that because it's showing you that the rainfall's hitting the vegetation and not making its way through.
Yeah, so different vegetation types, and then we can look at like evapotranspiration rates and how that would change. So the 4 lysimeters that I work on, they're all the ones that are split into 2. We have like so like we did with just bare soil, green grass over there. This is like a shrub which isn't looking too good at the moment, and then another shrub. So we wanted to look at the differences between these 2 shrub species and see how they manage and change water rate within the soil. With regards to the just do experiments, what thing will with, or just like field tank, as in take examples of vegetation found field. Yeah, good question. So these are like monocrops. So because we didn't want to mix vegetation species, because then we'd get kind of more varied response. So these are monocrops to look at 2 different. This is like a perennial and an evergreen kind of crop species. Probably wouldn't find SuDS systems monocrops within like. I think these are probably more characteristic of what you find within like urban area SuDS, and this one as well. So it's more like kind of varied. But I think the idea behind this is to kind of work out whether the woody shrub species or kind of more grassy species, whether they're more efficient and better at kind of preventing flashy flood response, really.
And I think I can just add to it in that a lot of the methods that we have on the street don't always have to apply to an urban location. So we've learned a lot of research through stuff like what Dr. Paul Quinn does in the rural catchments and higher upstream. We're testing a lot of things here. I mean, it's scaling it up from what's in a lab, and it's at a street scale, but then from that you can scale this up into a catchment scale. So you'll learn a lot more about scale and scaling it up and putting data into models and stuff further along as you go in the course.
Cool. So we'll move over to the ensembles. So I just take this. So again, same sort of thing over here within the ensembles. Lots of hidden sensors within here. This over here, it looks like a kind of thing that you would help the tree establish. But we have one of these. I don't really know too much about the sap flow measurement, but it's measuring kind of
water intake, yeah,
from the tree, and how much. Again, it's all about this mass balance. So inflows, storages, and outflows, and within. So we have again the outflows, which would be comparable to what's in those drainage cabinets as well. So we can look at the inflows from the rain gauge, storages with potentiometers, volumetric water content sensors, and then also the outflows from the tipping bucket flow gauges. Is there anything else to? Yes, and here as well. So I don't know if you look up the street, which way does the pavement slope? Okay, so directing it down towards the road. So obviously that's not good for green infrastructure, because we want water to flow into these green areas and kind of manage the flows more slowly and kind of slow the flow. Whereas like planning legislation at the moment, when they were building this side, they said no, we need the pavements to slope towards the roads, towards the drains. So a way of kind of capturing that surface water flow and measuring it is we have these strip drains here. So if you look kind of closely at that, you can see it's basically just like an empty kind of channel, and that flows down towards the kind of sump areas that we have, and again that goes into the bucket flow gauge, so we can quantify the runoff from the pavement. It doesn't obviously capture all of the water going into the drains, but at least we have some kind of quantification of the levels of surface water runoff on the pavements. Did Paul show you the virtual tour as well?
I think he's going to.
Okay, so you can see like kind of an idea of what this would look like during the construction phase on the virtual tour. I think we've got like an image showing it, because it just basically opens up and you have a pipe there, and it will go down into the sump. Anything else that we need to cover? See, all the data goes up to the API, so we have like a system where our data is managed by the Urban Observatory, and that's available in real time to the public, which I'm sure Eleanor will talk about more.
Yes, and maybe also to say that if the site interests you, think on it sort of when you get further down your degree and you've got to choose your MSc topics, because we often have, because we've got it on our doorstep and it's a really good place for capturing data and fieldwork and modelling stuff. A lot of students over the last few years have been doing individual projects, so they'll come over the summer and do experiments on the plots, they'll change things, capture data, same with the swale as well, so it's a good site for that sort of thing.
And I think with the data being available online as well, you can access quite like long data sets. So we've been collecting data since 2017. So we have all of that rainfall data, all of the flow data, and see some of the lysimeters are new, and some of the ensembles are newer. But a lot of them do have data going back to 2017 as well.
Should we show them the depression one?
Yes.
I'll show you some of the grassy ones. Yeah. So Daniel was mentioning about the rain gauges, so the white buckets on top of each of the lysimeters. We've also got one down here that's called a pit gauge, so it's at ground level. And that's been a lot of research has been done at Newcastle University in our department through PhD projects and other research projects into how rainfall can be monitored effectively. So wind is a big factor in how much actually goes into the bucket. So those up on the top over there will obviously pick up different values to something that's at ground level, and apparently the pit gauges are supposed to be the better ones for that sort of thing, and the impact of wind-induced undercatch. So that's those. Well, in this case the vegetation has grown and it's starting to change how that will behave, but essentially you don't often get too many rain gauges in a city location, so this is obviously a research street and we've got lots of them monitoring at plot scales, but where you put your rain gauge like that to do with vegetation and rain shadows, that does make a big impact on your results, so careful design of things like that is really important. And we've also got another rain gauge right up on the roof up there, so obviously you can imagine the wind and everything up there is very different, and we have analysed data, and weirdly, even though we're on the same street, they do collect very different data.
I think on that point as well, what you were saying about like the rain shadow and the vegetation kind of shielding it, we know that these lysimeters are in close proximity to the building, so we're obviously going to get some kind of rain shadowing effect. So these are more, the rain gauges on the lysimeters measure like kind of plot scale rainfall, whereas this is our kind of site level reference point for like, you know, a wider site level rainfall, and I think that's probably more accurate, but those do give a picture of what's falling actually directly onto the plot.
But I guess the prevailing wind for here is this way, so that building does shelter the street slightly, but it's the nature of what we're doing, and you know, really local monitoring, so it's quite important to have quite a few of them on the same street.
So with these ones as well, we're working on well, we're going to probably put it in the next few months. We didn't want to do it during lockdown because we didn't want like another, well, a water leak, but we're going to kind of take the rainfall received and then augment it in real time using a runoff simulator. So it will we'll be able to work out every hour how much rainfall we receive on the plot, and then we'll upscale it to account for like runoff, because they're not at street level, they're raised up, so they don't get any runoff whatsoever. But we'll kind of upscale. Sorry, I'm just keeping an eye on that. Do we know that guy? Because I have one of the lysimeters open, I think.
It's okay, it's just on a drink.
Okay, so would be it. Yeah, so we've got like a runoff simulator which will take the rainfall and upscale that to a factor of 10 to account for any kind of greenfield runoff from those if they were at ground level.
Let's have a quick look at this one and then we'll head to the swale. It's a grassy one. Do you want to take this, Danny?
Yeah.
It's alright to talk at the same time.
Okay.
So these are grass plots, but what's different is this one has got 3 depressions. So Daniel was mentioning about the rainfall simulator. Putting one of those on and doing an experiment on the same day and seeing the difference in the runoffs, and also obviously the tip and buggy flow gauges are underneath here and they're all connected to a lot of boxes. So we've got natural events, we can also monitor how that performs. They're very small, but just if you think about if we had a rainfall event, a very heavy downpour, if water collected in those depressions and then we scaled it up, it could have quite a big impact on the city. So it's just another little demonstration to show what can happen if the difference in outflow if you're collecting it in those depressions. We have had students do projects on this before, and got this to do something as well.
We can combine that with modelling as well, like numerical modelling to work out, you know, the effect of these small scale depressions. I know some people did a study and it was like if they did this in 20% of an urban space, then you could reduce urban flooding by like, you know, 60%. I can't remember the details, but it was quite a considerable amount because of these surface depressions.
I think the thing when you're doing catchment or urban management, it's really difficult to get the data because you have to implement it for it to, you know, to monitor it, and to scale up and put it everywhere. It's not realistic because it's not happening in the real world. So this street gives us that opportunity to demonstrate it to people in the city, demonstrate it to the public, and then put it into models, scale it up, see what would happen if we got more locations around the city. What impact would it have? You know, if we had a big winter one or a big local connected one in the summer, it makes a big difference when you scale it up.
Is the sump open? Maybe we have the sump there, is it open?
I don't know.
Should we try it and...
It's not meant to be. No.
Oh.
So it's like a chamber that we can crawl into and log similar things in the cables as what you saw over there. Right, I'll pass it back to you. Right, so we go to the swale at the bottom. Right, do you want to head down to the bottom of the street and then... So as you probably realise that this street's open to the public 24/7, and so we've got a lot of signage of trying to engage people to understand what we're doing as research, and trying to help them to understand what these features are doing for their local area. And so we've done a lot of work from community level and just people passing by right up to government level. We've also built up the evidence and confidence to say these are new measures, they're not everywhere, they're not your traditional hard flood defences that you see in a river or whatever, and trying to demonstrate through our research and quantifying it with the results to say, look, this works, you know, and trying to get people on board, allow them to put it in their community, allow politicians to get on board and put it into policies, and it's all about building up the evidence base so that you get the confidence to do it. So a lot of having the street open, and we have demonstration days, open days. We've had lots of people coming to see Daniel's rainfall simulator. He did that once, and I've done the swale demonstrations, and it just helps them to see it visually. So it's easy to talk about things, you know, as a presentation, but physically coming themselves and seeing it makes a big impact, and it helps people to understand how it works. So Daniel's mentioned the lysimeters, the ensembles. So the other main feature we've got is the 140 metre long swale. And really the best way to see this is actually from the rooftop, which we can't do today, but you'll see some other stuff along in your course, and you'll be able to visualise it better in that way. But essentially, above the swale there's a plot of land which is going to be developed, but at the moment it's brownfield. That is part of the water catchment that comes this way. And back in 2012 there was what was called the Toon flood, and the water just rushed all the way down the top of that direction towards the city centre to cause a lot of chaos. Now obviously you can see around we're developing a lot. You need to mitigate that, so you have the sustainable drainage in place, the mitigation measures to slow the water back down. So that swale is designed so that the water on the top of the catchment pushes to the top, and it's got a sort of basically a tortuous flow path to slow it right down, capture it, store it, filter it, so that it's not going down into one of the normal drains basically. So we are monitoring it really intensively using sensors under natural events, but we can also use it for experiments. So Daniel mentioned about the rainfall simulator, and sort of you have an experiment day where you can put water into something. We physically put water into the swale and we generate a real flood. We release the water and our sensors pick up what happens, but we can change the design very slightly, and we can quantify that to help inform design for future schemes and people working in this area. We'll walk along the swale to have a look at it, but if you've got any questions as we're going along, just shout and I'll keep talking as well.
I think that's a key point about the site. We can monitor like natural events, but then also simulated events or kind of semi-natural events to get the hydrological extremes that we wouldn't usually witness.
So the entrance to the swale we've just come in, wrong end to start talking about it basically, but this is the bottom end where the wetland where it stores it. But before that, so upstream, this is what we call our experiment area, and we've got lots of different features in there, gauge boards, we've got sensors poking up out of the ground, and these are all so that we can invite people to watch it or to monitor it for research, and to really tweak the design and really understand how those small changes occur, and the impact it has on the flow and the flood. It's difficult to monitor something like this out in a catchment because you're not always there. You know, a flood comes really quickly, you can't always have lots of equipment out, it's hard to wire up sensors in a rural location, you might not have the data connections. So we're very lucky that we have the university right by, we can have the power, we can have the connections to the Urban Observatory's API, and that is really difficult when you're out in, you know, high up in the top of a catchment. So we benefit from that. And so basically I've got 16 water level recorders and then a couple of backups, and they monitor water level every 10 seconds. So that's really fine resolution. The reason why we've done it 10 seconds is because if you have a flood wave that dumps water on that catchment, it comes down, that flood wave comes really quickly and your hydrograph goes right up really quickly. And also if we're doing experiments, it just means we can get that increment of the hydrograph going up, the peak, and then it coming back down again. So it's really important as resolution when you're looking at the data as well. So we'll keep walking and have a look. I'll stop when we get to the leaky barriers and you just have a look whilst you're walking along. So I mentioned obviously we've got the rain gauge, that's telling us what's coming into the system. We're measuring the water level and we can do calculations and volumes and flow. We can get more equipment out during experiments, and we can build that picture up of how we're slowing the water down, how are the sort of what we call the nature-based methods, how are they interacting with the flow, and how is it stopping it from charging all the way down, you know, putting more things into it to make it a tortuous flow path. One of the examples that we're looking at the moment is the long grass. So we've had lockdown, not been able to come to keep managing this feature. So management of flood is a big area of work as well. So we've not been able to come and cut it. We've left it, but we've used it as an opportunity to look at how rougher surfaces interact with the flow. So surface roughness is a big thing for hydrology in terms of, especially if you're modelling, you have to set parameters and say, oh, it's a smooth surface versus a really rough one. So we're just trying to see basically what the different grass lengths are looking at. So when I say when we do experiments, what we do is we fill the reservoir, which is at the very top, we close the valve, but when we're ready to release the water, we open up the valve, so that's Richard, our technician, does that. The water comes down, the sensor starts to detect the water, and it'll back up against the bottom there. So that'll be first run and say we've got the leaky barriers at design. Then what we do is we have a pumping system that basically recycles the water all the way back up to the top. We can then come in, change the leaky barrier design, make it something we can completely remove the barrier, so we've got a no barrier and a barrier scenario, and then we'll release the water again, and you've got really good comparisons on the same day with the same conditions to quantify the difference. So that's the main thing with the experiment. We'll keep walking up and you can have a look at the reservoir, but just shout if you've got any questions.
What are these blue little flags all across the...
Yeah, that's a good question. They're not to do with us. I think they're doing the seismic monitoring.
It is, yeah, seismic monitoring. I don't know the details, but I guess they're really, really long rods that have vibration sensors in.
Yeah,
or
they've only just appeared, and the data, I've noticed the Urban Observatory portal on the website, you've got some seismic sensors which probably in the same format as those. But literally it was only last week that they got put in, so I think it's watch this space with it.
It's not to do with like the bending of hill slope stability, is it? Like really long rods and it bends, and they can detect that.
Yeah.
But
Yeah. Right, we'll have another quick walk up before Paul comes in. So you can see the white tubes that are sticking up, those are the water level sensors.
these here as well. This is some sensor wires which we got this kind of redone. So that just shows really the sensors come up here and then they would go down to the sump usually. But that's a work in progress. Slowed down due to COVID.
Like everything else.
Yes.
I mentioned what this was, but there's the water where it comes down. It's on purpose directed into this bit, and then it's got to go through another one, then a set of barriers, then some baskets, and then back into the wetland, and the wetland stores it. But this is basically where we fill it up, and we can close the valve underneath there to hold the water back until we release it. And I don't know if you can see over on the bank between the two flags, that's the pipe that comes out where the water gets recycled back round, so it's quite interesting to watch.
What kind of volumes?
So that ruler and so we've had a laser scan done of the swale, and we've worked out at every level what is the volume, and we're sort of releasing around 100 metres cubed, so it takes a long time to fill and then not very long to release.
Yeah.
So you're looking at that sort of thing. That's like an extreme flood. In the natural events you'd probably get, you have it but spread over a longer period of time, and depths don't get too deep.
Eleanor, I think maybe we should give them some leaflet packs as well after this. If we give you a leaflet pack, that will have like all the link to the YouTube videos, so you can see this like, you know, in action during an experiment, and you can see within some of the lysimeters. Yeah.
Should we go?
Yeah.